So let's talk about this bearings question. So first of all, what is a bearing? Okay. A bearing is essentially just a method to measure an angle, but it's standardized. Why do we standardize it? Like if a guy is in a boat on in an ocean, right? And all he has is a compass. How is he gonna explain where he is to like a radio tower over there? Okay. The thing is, if he looks at the compass and he makes a north line and then he says, okay, I see you at about 203, or no, this is about 310 degree rotation, the clock tower will realize, where each of them are. You see what I mean? So this angle is called a bearing. Again, I kind of used a very difficult example, but let's say that there's another boat. So this is A and this is boat B. Now, only A can see B. Okay, so how does A describe where B is in his perspective? He tells you what angle from the north line you are. So like this angle, I had to look 20,
You cut
30.
him.
Uh-huh. Oh, can you hear me now? Hello? So basically this angle is called a bearing. So how do we define bearing? It's basically the clockwise angle from the north line. Okay? So like for example, a bearing of 40 degrees would mean this angle. A bearing of 120 degrees would mean this is the north line, right? 120 degrees is roughly over there. Right, so this bearing is 120 degrees. We don't normally draw an arrow to specify that we are rotating from the north line. You see? So this is how bearing works in general. Like that's the idea of bearing. Is this clear, Amy?
Sorry, yeah.
Yeah, this makes sense, right? Okay. So now, for all bearing questions, I mean, obviously we're supposed to use the SOHCAHTOA, we're supposed to use the sine rule and the cosine rule depending on what the situation is. But there's one additional thing that can help you a lot in bearing questions. There's a rule about general angles that if you have two parallel lines, okay, and you cut them with any line, okay, the angle between those two parallel lines, these two angles, will always add up to 180. So angle A plus angle B will always add up to 180 degrees. Okay, so this rule is extremely useful for bearings. Why? Because bearings questions have a bunch of north lines in them, and every north line is parallel, which means that if you have a line, then this angle and this angle must add up to 180 degrees. Okay, so this will be very useful for bearing questions. Another important thing, I mean, this is almost obvious, but remember that if you have a straight line and you cut it into two parts or many parts even, all of those parts must add up to 180 degrees, right? Because a straight line's total angle is always 180 degrees. And similarly, a full circle will always add up to 180 degrees also. If you cut it up into a bunch of, parts, all of these angles will add up to 360 degrees. You guys know all of this, right?
Yeah.
These two things. Okay.
Yeah.
Just remember that this will be the most important rule out of anything in the beginning of every bearings question. Now here they're nice enough to draw the diagram for you, but sometimes you have to do it yourself. Let me explain how to do that because that's a very common situation. There's a ship that leaves port A, so make a port A random, okay, on a bearing of 30 degrees. Now, when someone says draw this bearing, first make a north line and then make 30 degrees from that north line. Okay. The only thing I ask of you is to not make it illogically because 30 degrees cannot be more than 90, right? So do not draw that as 30 degrees. Of course, if this is 90, then 30 must be somewhere here, right? Now, how long must this be? It's still 25 kilometers. Let's just draw a bit of a longer line. Bigger diagrams are always easier to work with. Make them a bit exaggerated. It'll help you. 25 kilometers. Now, this is where you're at B now. Okay. At B, you change your bearing to 100 degrees. Okay. Which means that you draw another north line. The moment someone says draw bearing, the first thing you need to do is draw the north line. Now, 100 degrees, because this is 90, 100 would be a bit under 90, right? So this is 100 degrees. And you go for 40 kilometers, meaning you have to go a bit longer than the 25. Maybe I made it too big. 40 kilometers. And then finally you reach your point C. Okay, so this is your diagram. Now, the first question is, a second ship leaves port A and goes directly to C. Okay, this is like Monopoly almost. So another ship is starting at A. Instead of making this whole journey, it goes straight to C. Okay. Now, so this is your second ship, and the blue line is your first ship's movement. Okay, the first ship was kind of stupid, or maybe they had to stop at B. I don't know. Anyways, so we need to find the distance that the second ship will travel. What does that mean? What are we trying to look for?
Mm,
Which part of this
the
triangle?
length
Uh-huh,
from A to C.
exactly. We're trying to find the length of AC. Good. Now, how do we do that? The first thing you should do is, in a bearing question is, um, write down all the things that you indirectly know because of these rules. Okay? So the first thing I can say is that I know that this, well, let me do this in a different color so it's obvious what the working is. Let's say orange. The first thing I know for a fact is that this angle, what is this? What do you guys think? You see two parallel lines and a line between them. So what should this angle be? Or
180.
no, they're supposed to add up to 180. This and this is supposed to add up to 180. So what is this? Hmm?
Um, is
This
it 150?
150, exactly, because you can just do 180 minus 30. So
Mm.
this is 150. Good. Now, here's a cool little thing. If we know this is 150, then we can actually also find out what this angle is. How?
Because a full circle is
Exactly. So can someone tell me what this is going to be? Actually, Amy, can you tell me?
so a full circle is
60.
360
Uh-huh.
minus 100 would be 260 minus 150 would be 110.
Yep, perfect. So now we have everything we could have pulled out from this, right? Okay, so now let's see if we can find out a way to find AC, the length of AC. Any suggestions?
Could we do the scissor
Which
method?
rule though?
The cosine.
Can you guys hear me now? I accidentally
Yeah.
unplugged my. Okay,
Yeah.
so yeah, exactly, the scissor rule from cosine. So maybe Amy, you can set it up for me. Try to do it.
Um, so it would be
Which
we're
side
trying to
should be the
find,
subject? Let's start that. Hmm.
would the subject be the distance between A and C, so x2?
Beautiful. Let's call
Oh
it
yeah.
AC, AC square.
And then it would
Equal.
equal to 25 squared plus 40 squared minus 2 times 25 times 40 cosine 110.
Perfectly done. Good job. So can you try to solve this on your calculator and tell me what you get? Okay, I accidentally ended the previous recording. I didn't know. So yeah, we have 54 kilometers right there. Okay, let's look at part B now. Part B says find the bearing of the course taken by the second ship. What does that even mean? That means that when the second ship was starting to move, right, from A, what bearing did it move at? So if we think about this, it's basically moved at this bearing, whatever that is, right? Because
Mhm.
that's how you define a bearing. So we basically need to find out what this whole angle is. The thing is, we already know part of it at least. We know 30 degrees. So all we really need to find is this angle. Because, we can add it to 30 later and get the whole thing. You see what I mean?
Mhm.
So we will call this the bearing of the second ship. Do you guys understand why? Because this is the direction it was heading in, and this is the angle for that direction. Okay, so how do we find that angle? We call it BAC basically, right? You see this part?
So
BAC.
yeah,
Yeah. So what are your suggestions?
would we minus it from 180 to 30?
No, because that would be the case where if we were trying to find this whole thing,
Okay.
the angle on a straight line. And also, if you think we can do 90 minus 30, that's also not true because I never said that this is 90 degrees. Don't go for the looks. You see what I mean?
Mhm.
So we have to use some kind of trigonometry to do this. Which kind though? So by the way, we know what this is now.
Oh, so would it be like the inverse?
We would have to use the inverse at some point in the equation, yeah, but which rule do we use basically?
Um, would it be the sine rule?
How? How do you know that you have to use the sine rule?
Because the 50 has a pair with 110.
50
Oh,
has a pair with 110?
54,
54, yeah,
sorry.
exactly. So we have one full pair of a side angle, and we're trying to find another angle whose side we do know. So that is exactly the sine rule. Okay. So can you help me set it up?
Um, would it be sine 110 over 54
Equals.
equals to sine x, could you say?
Yeah, we could call it BAC by its actual name, right?
Yeah.
Divided
Oh,
by.
40.
Good. So can someone solve this and tell me what you get?
I got 44.18.
Okay. Let me see. That's 44.1 what?
18, or it's 1789.
So that is, you're gonna lose an accuracy point for that
Mm-hmm.
because it's actually 41.1, just one. So if you do 1/8, it's 2, which means that you've actually made a mistake in the solution. Now, it's very minuscule, but it's something that can cause you a lot of trouble. This is what you did, right? You found sine 110, and it was 0.9396926, and then later you used 0.94 maybe, or zero point 0.9 for that.
I just plugged in like the sine 110 times 40 over the
Hmm. Oh,
53.9355.
wait. See, then that's weird because you shouldn't have had the mistake then. But
Because I got 44.1789.
yeah, 1789. Yeah, you should have gotten, so 40 sine 110 divided by 54, and then sine inverse of that should be 44.1124. That's what you should have gotten. So did you do four? So can you write it like this? 40 times sine of 110 divided by 54, and then don't use the decimal version of this, okay? Use the
Mm-hmm.
answer key of your calculator and say sine inverse of answer, like that.
Yeah, that's what I did.
Okay, weird then. Um, are you sure you're in degrees and not radians, by the way?
Yeah, I am. Hold up, let me try it again.
So that's the end of the bearings one. This is basically, this question is transferable to any bearings question because they're all essentially the same idea. Okay. Even these parts, like these questions that they've asked, they're similar. Okay.
Mhm.
One more thing I want to tell you guys about is this. Sometimes they say this. For instance, in this question, they could say, what is the bearing of the point A from point C? What does that mean? This means that if you were standing at point C, because it says from point C, right? So if you were standing at point C, what bearing would you need to look at? What bearing would you need to turn to look at point A? Don't make the mistake of saying it's this angle because bearing is not calculated anti-clockwise. It's actually this angle. So basically, if you were standing here and I told you the only thing you can do is rotate clockwise and I tell you start from north, you would need to rotate this much to look at A, right?
Yeah.
So that is called the bearing of A from C. From is the point where you are standing. Okay, be very careful about this. And you can, by the way, find this answer very, very easily because you already know this angle, right? So let me clarify. So you already know this angle. It is 44.1. Now, since you know this angle and you know this angle, you can find out what this angle is by just doing 180 minus 110 minus 44.1, right?
Mhm.
So that's going to be 28.9, 25.9, sorry. So now, if this angle is 25.9, I can also find this angle. Anybody take a guess? How can I find this angle?
Is it the 180 minus 100 from the...
Exactly, because we see two parallel lines and we see two angles between them, which means that this part and this part must add up to 180. You see, Amy?
Yeah.
Yeah. So this angle is going to be 180 minus 100, which is 80 degrees, which leaves me with almost a full circle. The only part that I don't know is the part that I'm trying to find, which means that this angle is simply going to be what? This bearing part.
Sorry, can you say the question again?
So we're trying to find this angle, right?
Yeah.
Why are we trying to find this angle? Because this is the bearing of A from C. Okay, that's a new question I made up. Now, so since we know this part and this part, how can we find this missing angle now? The thing is, my
Oh,
clue to you is that we know everything we need to know to find this angle.
the beam.
So do you agree that this is a full circle?
Yeah.
So, and what's the total angle of a full circle?
360. So you'd minus the 2.
Exactly, because we want everything except the 80 and except the 25.9, and that is this angle, which is going to
Yeah.
give us basically 254. So this is how you can find out these kind of questions, okay? As you can see, it's only these three new things that you need to remember, okay? On a straight line, the total angle is 180. On a full circle, the total angle is 360. And between two parallel lines, remember that between any two north lines, any line will have a total angle of 180, okay?
Mhm.
So then when you add them to become, so this is going to be like the most important thing in all bearing questions, okay? And that is it. So that's all you need to know about bearings. Let's look at the next one. Okay, so this question is a bunch of triangles now. And what is given? So everything given is on this diagram, I assume. Let's look at how to find AD first. Now, um, if you look at this triangle, so whenever you're given a thing to find, you need to scan all triangles and see which one has enough information for you to be able to find the thing you need to find. If I look at this triangle, I don't know any lengths of this triangle at all. So it's impossible for me to use sine or cosine rule because both of them need at least one length, in all cases. However, if you look at this triangle, it looks pretty interesting. Which case of what rule do you guys see here if I'm talking about finding AD?
The cosine rule.
Exactly, because you have the scissor thing happening, two sides and an angle between them. So we can set up the formula like this. AD squared equals 9.2 squared plus 7.1 squared minus 2 times 9.2 times 7.1 times cosine of the angle between them. So I'm going to find AD 9.2 plus 7.1 minus 2 times 9.2 times 7.1 times cosine of 60, which is, when you square root that, it's going to be 8.35. Perfect. So we know AD now. Remember to keep track of what you know. Okay, it might even be useful to write it here. Now find DE. So we don't know this side now. What do you guys suggest? What can I do here? We have one full pair. That's nice. But we don't even know this guy's angle though. We can't use sine rule yet, can we?
Can't you just 180 minus 110 and then minus 52 to find that angle?
Amy, why do you think that is?
I did the same thing, and
No,
is
but
it
why can I do that? Why can I subtract this and this from 180 and get this angle?
because it's like, how do I explain it? It's only that it's a straight
Because
line.
no. No. The inside angles of a triangle add up to 180. That's why. So this is whatever is left over from 180 once these guys have taken their bite. So this angle is going to be 180 minus 110 minus 52, which is 18 degrees. So, Amy, can you set up the sine rule for this case now?
Yeah.
hmm
So it would be sine 110 over 8.35 equals to sine 18 over x.
Exactly. Let's call it DE. We don't need
Yeah.
to name new variables if we already have the side names. So
Yeah.
can you now solve this for DE and tell me what you get? So the answer ends up being 2.75. Now, the next question is, so did you guys do B by the way, or no?
Yeah, I did B, but
Yeah.
Okay.
The
So,
rest was.
mhm. So part C is finding the area of BCD. So basically this area. Okay. Now, to find the area, we will use the formula that says, two sides and the angle between them, basically. The only problem is we know the two sides, we don't know the angle between them, do we? Like, we would need this angle
Mhm.
to be able to find the area. So how do you guys suggest that we find this angle now? It's actually a pretty tough looking question. Oh wow. Okay, so I misread the question. It says the area is given, and you want to find that angle, the one that I realized that is impossible to find. So we're going to use this formula for the area. So again, the area formula works like this: 1 over 2 times side A times side B times sine of the angle that we didn't, of the side we didn't use, right? For example, in this case, we know 7.1 and 3.2. This is the angle between them, which is unknown in this case. This is essentially angle B in this case, for example, or DBC we can call it. So we're going to set up the formula. The area is known 5.68 equals 1 over 2 times side number 1 times side number 2 times angle of sine of the angle between them, which we do not know. It is DBC. Okay. Why is it DBC? Because this angle basically. So we need to find DBC. Now can you guys solve this for DBC and tell me what you get? So we found out that DBC is 30 degrees, and the next thing we need to find is AC, which is, oh wow, okay. So we need to find this length. Okay. Okay, this is easy. Because look, if you look at the triangle ABC, you will realize two very interesting things. First of all, since we know what DBC is, we know that this angle is 30 degrees, right? And here's an interesting idea. Do you guys notice anything funny about this whole angle? Look at the angle ABC. Do you notice anything interesting about it?
it's a 90-degree angle.
Exactly. This is a right angle triangle. We've just learned that because this is 90. 30 plus 60 is 90, which means that finding AC is as simple as using any one of the billion techniques we can use at this point. We know this. We know this. We That's pretty much all we know actually. We don't have a billion techniques. I exaggerated. I'm sorry. We only have one. What are we gonna use?
The scissor, the
No.
cosine.
We could. That would be overkill. But there's
Okay.
a poor guy who died millions of years ago, Pythagoras. He said that you can find the hypotenuse with, in a right angle triangle, if you
Oh,
know the
so
other two sides. So cosine rule would be the biggest overkill of the century, probably. Um,
2
mhm.
plus
Yeah,
b.
exactly. AC is gonna be 3.2 squared plus 9.2 squared, the square root of all that. That's your answer. And just to finish this off, let's move on to the next part. We have to find the area of the complete thing. Now, we already know the area of this ABC part, right? Let's clean this up just a little bit. So we already know the area of ABC, so that's nice. We need to find the area of this guy and this guy, right? So triangles have a very nice formula, which is that if you know any two sides and the angle between them, much like the scissor rule from cosine, you can use this formula to find the area of that triangle. So let's look at this one first. Which two sides and which angle should I use for this case? Can someone, Amy Ashley, can you tell me? So I want to use this formula. This formula uses two sides and an angle between them. So which
Mm-hmm.
two sides and an angle can I use in this case for this triangle?
Can I see the? So we're looking for the area.
Mm-hmm. So which sides and which angle should I use in the formula?
Mm,
Any two sides and the angle between them.
so could you do 7.1 times 9.2
Mm-hmm.
times sine 60?
Exactly. So we can find the area of this by using this formula. And finally, we can look at this guy. There's a little problem, I think, or okay, we already know what DE is. DE is 2.75, right there. So, which two sides and an angle can I use, Jessica, for this one?
So it's 2.75 times 8.35 and then times sine 52.
That's it. So you can basically find this area, add them up, and they already were nice enough to tell you the area of the third triangle. Add all of those up, and you got your 5 points. This is a very simple question, by the way, extremely simple question for 21 points. That's a lot of points. Okay, so make sure you understand this, all the steps in this, because this is very general. It's a very common question. It's not supposed to be very difficult. The next question in the list, by the way, is extremely similar to this one. So make sure you try that out yourself, okay?
Mm-hmm.